everyone, sorry for the break in the video. Let's pick up where we left off with sample spaces. Sample spaces are the set of all possible outcomes of an event. So if I flip a coin, there are two possible outcomes. You could get a heads or you could get a tails. If you rolled a number cube or a dice, there are 6 possibilities. Okay. The fundamental counting principle says you can find the total number of outcomes by multiplying the number of each event. Multiplying those together. Okay. So number 1, find the number of outcomes from picking a number from 1 to 4 and choosing the color red, green, or yellow. There are 2 things happening in this problem. First, we're picking a number. Second, we're picking a color. So when we're picking the number, how many options do we have? We have from 1 to 4, so we have 4 options. And when we pick the color, how many options do we have? 3. Now, that fundamental counting principle I just mentioned said if you multiply these, you have 12 possibilities. Now, obviously, you could list them out. 1 red, 2 red, 3 red, 4 red, 1 green, 2 green, 3 green, 4 green. Or this is much more efficient, and you would get 12 total options. How big is the sample space for choosing a blue, white, or green shirt with khaki or denim pants? So first we are choosing our shirt, and then we are choosing the pants that go with it. So when we pick the shirt, we have 1, 2, 3 options. When we pick the pants, 1, 2 options. Multiply those together, how many total possibilities? 6 possibilities. So take the number of each decision that's being given, multiply them together. Probability is the chance of an event happening. So to find the probability, it's the number of the specific event that you want to happen out of the total. Okay? So if I have a bag of marbles and I have 8 blue out of the 20 total. Okay? That is what you're looking at. The number of the specific they want divided by the total. Now you can write probability as a percent, a decimal, or a fraction. Okay. A spinner has 2 red, 8 blue, 2 green, and 4 yellow spaces. Find the following probabilities. So first we want to know the probability of landing on red. So our specific event we're talking about is red, so that's going to go on top. So how many red are there? 2. Out of how many total? Remember, probability is always the number of the specific out of the total. Okay. And our total would be 16. Okay. They may ask you to leave it as a fraction, which you would simplify, or you could change it as a decimal. 2 divided by 16. 0.125, or they might ask you to make it a percent. Okay. So to change it to a decimal, 2 divided by 16, and then to make it a percent, move it 2 to the right, 12.5. All 3 of those would be good answers. So the next one, the probability of landing on green or yellow. So this time, our specific is green or yellow, so I have to get the green and yellows. So 2 and 4, how many options is that? 6 out of the total 16. The total hasn't changed for our spinner. You could either simplify this, or 6 divided by 16, 0.375. could also be one way it's written. Or if I make it a decimal, 37.5%. All would be ways to show that. Number 3, the probability of landing on not blue. So if it's not blue, what can it be? Red, green, or yellow. So I'm going to have to add those 3 together. 2 plus 2 plus 4. 8 out of the 16 total. So not landing on not blue, you're going to have to add those other 3 together. That would simplify down to 1/2. Or 8 divided by 16 is 0.5. Move it once, twice, 50%. I'm guessing it's going to either be written as 0.5 or 50%, but I'm not sure. So just know that you can write probability as a fraction. You could simplify this as a decimal or as a percent. This next set of problems, we're going to look at this table and use that information to find the probability of each. So given this table, find the probability of picking a teacher that has a cat. So if this is my whole group of people, I want a teacher that has a cat. So here's my 6. So 6 out of how many total? So I have 6 options that would work. And if I add all of those together, get 74, hopefully. So there are 6 teachers that have a cat out of the total 74. Top divide bottom, or you could simplify. 0.08 or 8%. So you have a really small chance of picking a teacher that has a cat, which makes sense because there are very few teachers that have a cat. Find the probability of picking a person that has a fish. So if it's talking about a person, that can be both teacher and student. So how many people have fish? 14. Out of the total again is 74. You could either divide those both by 2 or write it as a decimal. 0.189 or as a percent. 18.9%. So probability, the specific number they want, okay, out of the total. The last couple of problems I have for us deal with a sample being biased or not biased. Biased is bad, meaning our data is not valid. Okay? The conclusions we make from the group are not really representing our whole sample. So, for example, if I decided to take a survey on campus, what the best major is, and I asked you guys, chances are you're going to tell me something about education, because you are all going to want to be education teachers. So I'm not really getting a good idea of the whole all campus because I'm only asking a group of education students. Same thing if I went to basketball practice and said, what's the best sport? Chances are they're going to say basketball. Right? So if you're going to be given a survey and getting information from people, you need to make sure that you are representing the whole population and that people are being randomly chosen. So if we took a look at a couple of these situations, we want to decide if these are biased or not. Stephen asks all the students that ride his bus, what do you think is the biggest problem in our neighborhood? 12 of the 16 students say that the biggest problem is that there are not enough things for young people to do. So Stephen decides the biggest problem in the neighborhood is that there are not enough things for young people to do. So he asked a group, and based off their opinions, he made the conclusion there wasn't enough things for people to do. The problem with this is that Stephen only asked the students that ride his bus. Okay? First of all, they are young, they're in school, right? And they're not really giving a good representation of the whole town, okay, or the whole neighborhood. There might be a lot of people who feel that the roads or traffic is the biggest problem. But because he only asked the students on the bus, this would be a biased sample. And this is also what we would call a convenient sample, which is bad. Convenient sample means the people are very easily accessible, right? They're a group that's right around them, so they can ask them very easily. If Stephen wanted to do a better job with this, he would make sure to go out and get a very good representation of the town. He'd make sure he had some older people, middle-aged, younger, so he had a good representation. So this would be not a good situation. Sue looks at an alphabetical list of the names of all the employees at her company. She picks every 10th name on the list and asks each of those employees how many years they have worked at the company. Out of the 84, she asks 14 say they have worked for 5 years or longer. She concludes that most of the employees have worked for the company for less than 5 years. How did Sue pick the people she asked? Every 10th name. So was it random? Yes. This was random, which is good. So this is not biased. Everyone had an equal chance of being picked, right? She was very random. She didn't pick specifically people she knew. She made sure that everyone had an equal shot. It was random. So her results are pretty good. So you are looking at, for these type of problems, biased, not biased. Was one group favored more? Did everyone have an equal chance to participate? Were they randomly picked?